Sometimes for various reasons, we want to rewrite an exponential expression in a different specified base. And especially, we often want to rewrite them with base e. So let's see how we would go about doing that. We are told in this example that we have a drug with a half-life of 11 hours. We start with a 200 milligram dose, and we want to start by writing an exponential function, any old exponential function, showing the amount of drug in the patient's system after t hours. Then we're going to rewrite the function in the form d0 times e to something times t. So we're going to rewrite it in a form that looks like the interest compounded continuously formula. How will we go about that? Well, we'll start with the half-life is 11 hours. So remembering how we constructed these things, our exponent is going to be t over 11. We start with 200 milligrams. We're working with a half-life, so our base is 1/2. And our exponent is t over 11. Okay, so that is an exponential function for the amount of the drug in the patient's system. We want it written with base e. So how will we do that? Our current function can be written as, well, our starting amount times 1/2 to the power 1/11th, all to the t. Right, I'm just pulling the t outside in the same way that we always do when we want to manipulate the exponential part of our expression. In our goal function, we have, well, the d0 is going to stay the same, 200, and then we'll have e to the k to the t. So we need to figure out what the value of k needs to be so that e to the k equals 1/2 to the 1/11th. I think we know what we're going to do here, right? E to the k equals 1/2 to the 1/11th. That means that k is the natural log of 1/2 to the 1/11th. And we can just throw that into our calculator like that. Or this might be a little bit easier to throw into the calculator if we use the log of a power rule and say that's 1/11th times the ln of 1/2. We could throw either one of those expressions into our calculator. So 1/11th ln 1/2, or we could just take ln of 1/2 to the power 1/11th, which I don't like mostly because it looks awful. Same number though. Either way, we'll get that k is about, we were meant to round to 2 decimal places, -0.06. Our d of t then is about 200 times e to the -0.06 t. And that's it. So there are formulas that you could memorize at this point involving exactly where the natural log goes, but it's really easier to just examine the structure of your function and solve an equation that looks like this.